Welcome to Chapter 1, Introduction to Operations Management. This chapter will be covered in two parts, Part A and Part B. This is Part A. Make sure that you also view Part B. These are the learning objectives for this chapter. You may want to pause the recording at this point and review some of the elements that we will be covering in this chapter. But basically, this is an overview chapter for the entire semester. It will give you some broad definitions of some of the operations management terms, as well as a few key concepts that we will explore in more depth as the semester unwinds. We'll begin with a definition for operations and also operations management. So operations is defined to be that part of the business that is responsible for producing goods or services. There's another common verb that is used in the definition of operations. It's actually used in the second definition on this slide, and that is the verb create. So operations and operations management is all about the production, the producing, or the creation of the goods and services that your company is in. There's a couple of other important words on this slide I want you to be aware of, and that is the word services. So operations and operations management not only is involved with a company that is producing a product, but also a company that is producing a service, such as a bank or possibly a consulting company. Finally, the word management, operations management. We'll see the word management appear many times throughout the semester. We'll see it used in supply chain management, total quality management, inventory management. Each time we see the word management, there's three elements that I want you to think of. The first element of management is planning. So planning is a major activity in which we, among other things, will identify all of the things that need to be done. The second element is organizing. So after we have identified all the things that need to be done, we need to decide how best to go about doing those things, how best to do them in the most efficient and logical manner. And the third element is control. So as we go about doing the things that need to be done, we need to have some mechanism for deciding whether or not we are doing them in the best way possible. And if not, making corrections to the way that we are doing them so that we do meet our objectives. So operations is all about producing goods and services. The definitions of goods and services is very straightforward, so these are just a few examples to make sure that we're all on the same page. So goods are anything that is physical, such as cars or computers or iPads or iPhones or anything that you may want to buy that's of a physical nature. Services are activities that provide some type of service. So you go on an airplane, the service the airline is providing to you is they are transporting you from one place to the other. Education is a service. And there are many, many other types of services as well. Within a company, there are primarily three major elements within the organization. We have a marketing function. The marketing function would also include the sales organization. So sales and marketing is all about how to promote and how to make contact with our customers and interest them in buying our products or our services. We have a finance and accounting department that is responsible for making sure that we are meeting our financial objectives and to provide the necessary financial reports that are necessary to manage the business. And then we have the operations department. That's the one, of course, that we are interested in. The operations department is going to be responsible for creating or producing all of those goods and services. There's one element of an organization that's not shown here that is often shown. If we have a company that produces a goods or service, we need to have an engineering organization. So the engineering function is going to be responsible for the design of the product that we are going to be producing for our customers. This slide shows a very important concept that we'll talk about throughout the course. We have a specific chapter that we'll cover later in the course on supply chain management. So a supply chain is defined to be a sequence of organizations, typically different companies, that are involved in producing and delivering the product or the service to your customer. So if you take a look at the diagram, you'll notice that the block on the far right-hand side says final customer. So final customer is the most important part of the supply chain. If we didn't have a customer that is interested in buying our product or service, then we certainly don't need a supply chain. Now, I made one little edit to this slide that may be different from what you see in your textbook. In the block just to the left of final customers, I've changed the title of that from distributor to retailer. And the reason why I did that is because most students are more familiar with a retail supply chain than they would be otherwise. So the customers are going to buy from the retailers. The retailers need to purchase the product from someone, and that's going to be the producer or the manufacturer who is going to manufacture the product. And the manufacturer, in order to manufacture the product, are going to need to get materials from direct suppliers. So the direct suppliers are going to be providing those component materials that are necessary to go into the product. And then those direct suppliers, in order to produce their components, are going to have other suppliers that they have to purchase for. Now, this slide is a very simplistic representation of a supply chain because, in effect, the suppliers' suppliers have their own suppliers, and those suppliers have their own suppliers too. And we could go back and back and back, maybe multiple times before we finally reach the end of the supply chain. Supply chains are extremely complicated, and that is the reason why companies are so interested in the management of their supply chain. Here's an example of a supply chain with something that we can all relate to, and that would be bread, a loaf of bread that you would buy at a grocery store. So if you look at the top of the slide, you'll see that the supply chain begins with a farmer who is going to be producing the wheat and to harvest that wheat that the bread will eventually be made from. The wheat will then be delivered to the flour mill, which is going to transform the wheat into flour. The flour is going to be delivered to the baker, who is going to take the wheat along with other ingredients, yeast and water, as well as other things, and to bake the loaves of bread. And finally, the loaves of bread, after coming out of the baker's oven, are going to be delivered to the grocery store where you or I, as the final customer, will purchase it. You'll notice that there are some dollar signs along the supply chain. Supply chains are also referred to sometimes as value chain. And the reason why is because as the materials move through the supply chain, certain value is added to them, and that increases the worth or the value of the product. So when you buy the loaf of bread at the grocery store, you are essentially purchasing the value, which is the accumulated value of all the individuals who have been involved in the production of that loaf of bread. Now I want to introduce at this point what I refer to as Professor DeLuke's 3 fundamentals. And these are things we'll be talking about all throughout the course. I try to keep it very simple, and I think that these are important as far as major takeaways for you this semester. And you'll also have, on a couple of exams, questions on Professor DeLuke's 3 fundamentals. So in the previous slides, we talked about the final customer, the supply chain customer. The customer is the most important person in the supply chain. So in order to produce and create our goods and services, we have to know our customer. We have to especially know what is important to our customer. What do they value? And what is it that they are willing to pay for? Now, the problem is that what customers value and what is important to them will change over time. So what is important to your customer this year may not be exactly the same as what is important next year. So it's important for every company to know their customer, know what's important to them, and to be able to align things so that they are delivering the value their customer is looking for. This slide shows the concept of process management. And we'll be talking quite a bit about processes throughout the semester. So hopefully in other courses that you've taken so far at this university or others, you have been introduced to the concept of a process. So the definition of a process is one or more activities, or in this case, your slide refers to it as actions, that is going to transform certain inputs into an output. So every process has certain inputs in order to begin, and at the end of the activity or the task, there is some output at the end of it. So we can categorize the processes within a company into 3 broad categories. And there are literally hundreds of processes within a company. So at the top level, we have processes that are important to upper management. So some examples of upper management processes would be the strategic planning process and the strategy process, where senior management will go through a series of steps and activities that will determine the overall strategy of the business. The middle level is the operations process. That's what we're interested in. Those are the processes that are going to be producing or creating the goods or the services that our company works in. And then finally, we have supporting processes. These are processes that are going to be supporting the core processes. And examples of supporting processes could be human resources. So in order to produce our products and services, we have to have skilled employees that are trained in certain areas, have certain knowledge. Other processes could be other training that we give to our employees to enhance those skills and knowledge that they come into. So this takes us to the second of Professor DeLuke's 3 fundamentals. So out of all the processes, especially the operations processes, there are just a few that are going to be delivering the value that our customer is willing to pay for. So we know our customer, we know what's important to them, then we need to identify which of the processes delivers the value that they're willing to pay for. And then once we have identified that process or processes, so most likely it's going to be more than one process, we need to continuously improve that process, always trying to make it better and better. Now, within each process, the one thing that we know for absolute certainty is that there will be variation in the process. This is a major theme of this course throughout the semester, process variation. So 2 slides ago, we talked about a process. Every process has an output or it has a result. And the output or the result will not be the same every day or every time that we perform the process. Therefore, we say that there is variation in the process. Now, there are a number of reasons why there will be variations in the process, or the output will be slightly different from one day to the next. And we can categorize those causes, those sources of variation, into 4 areas shown on this slide. So one would be just the overall variety of the goods and services that we produce. So if we have a product that comes in several different sizes or shapes or colors, each of those introduces a certain amount of complexity, being able to manage and control all those different sizes and shapes and colors. That alone will create variation in the process. The second one is demand. How many do our customers want to buy? By its very nature, the demand from our customers is usually very difficult to predict. We will study in Chapter 3 of this course different ways in which we can make our best estimate of what our customers' demand will be. The third one is random variation. So in every process, there's always going to be certain things that occur that generally are beyond our control. These could be things that are caused by nature. They could be things that are just generally something that we have no control over. So random variation is a source of variation that we typically don't have a lot of ability to work with. But the last one shown on this slide, assignable variation. This is the one, as operations people, we need to take note of. Assignable variation is something that has caused the output, the result, to be different. And whatever that is something that's going to be occurring every day, over and over again. And it could cause quality problems. It could cause other types of problems. So the challenge in operations management is to recognize that process variation is something that will always be there, but to try to control the amount of the variation and to try to limit the variation to the smallest possible amount. And we'll talk about some techniques for doing that in our chapter on quality control. So processes are going to be transforming material into some type of output. So we can see on the transformation process that we have certain inputs. Those inputs could be certain materials. They could be labor. They could be information. We have some process of taking those materials and somehow converting them into the output or the final product that we're going to be delivering to our customer. So, for example, a laptop computer. If that is the output that we are delivering to our customer, in order to deliver it, we need certain materials to begin with. We need a case, we need a keyboard, we need a display, we need certain electronic components, and the transformation process is going to be the assembly process of manually assembling them into a final configuration. And we see at the bottom of this slide a very important element, and that is the control element. So that's the third element of management that I referred to earlier, control. So we need to have some way of knowing whether or not this transformation process is performing to the standard and the quality that we wish for it to be. So in order to measure that, we need to have certain measurements, certain feedback that we take at various points in the process. We can measure the inputs coming in to make sure the input materials are good. We can measure the output to make sure the output product is good. And we can also take some measurements as we are going through the transformation process. We need to compare that to whatever our standard is, and if it is not meeting our standard, then we need to identify what the cause of the deviation is and what can be done to bring it back within standard. So this leads us to the third and the final point of Professor DeLuke's 3 fundamentals, and that is measurement. So to review quickly, we need to know our customer. We need to know what is important to our customer. We need to take that customer knowledge and we need to identify which of our processes are going to deliver the value our customers are willing to pay for. And once we have identified those processes, we need to undertake a continuous improvement of those processes. And finally, to see if we are continuously improving, we need to have some way of measuring that process. So by what will we determine whether or not the process is being improved or not improved? And those are the 3 fundamentals of Professor DeLuke's, and we will review those other times throughout the course. Now, goods and services. Every company is either producing goods or services. But every good or every service usually has a combination. It's rarely either pure service or pure goods. Here's a few examples. If you buy a car, well, the car is mostly product, is mostly goods. It's physical, it's tangible. But there's an element of service in cars, and that is they need to be repaired. So if something happens to the car, something breaks, you need to take that to a repair shop, and they're going to provide a service to replace or repair the broken element of the car so that it is now performing correctly. Home building, same thing. Sales is a process. Computer repair. Software development is a service, as usually consulting go along with the services, as well as the product itself, which is the software. And then finally, we have teaching and surgery. They're mostly services, but they do have an element of product. So you may ask, well, how does surgery, what is the product involved with surgery? Well, imagine all of the knee replacement surgeries, all the hip replacement surgeries that take place together. So the surgeon is performing the service, but as part of his service, he or she is going to need certain goods. The replacement knee, the replacement hip, or whatever. Manufacturing is involved primarily with goods, and of course service organizations are involved with the delivery of services. Goods are very tangible, physical. We can touch them. We can look at them. We know almost always exactly what goes inside of them. And services are a little bit more intangible because the service that we may provide to one customer could be different from the service that we provide to another customer. So, for example, if you have 2 cars that need to be repaired and you take it to a service place, the service that they provide on one vehicle may be different from the service that is required on another vehicle because each vehicle has their own individual elements of need. So within the manufacturing and service, there's differences. So manufacturing has very little customer contact, where the service industry usually has a significant amount of contact. The inputs that go into a good or service is typically fairly well defined in manufacturing, more difficult in service. Service industry generally has more labor involved than manufacturing. The uniformity of the output or the result is very tangible in manufacturing, whereas in service it can be quite intangible at times. How we measure productivity as one of the critical operations management measures we'll talk about in the second chapter. Typically in manufacturing, it is more easier done, more straightforward than it is in manufacturing. The service industry also has a number of different challenges. Now, I'm not going to go through all the items on this particular slide, but I do recommend that you read the textbook to talk about them. But generally, a service industry has more customer contact, and if there is a perceived quality problem in the service industry, generally it's more difficult to rectify a perceived quality problem than it is in manufacturing. So imagine, for example, if you go to a fast food restaurant and you arrive and you're waiting in line for placing your order, and for whatever reason it seems to be taking a significant amount of time for someone to ask you what you would like to order, and you eventually lose your patience and you leave the restaurant. Well, there was a perceived quality problem on your part. And like most people, the chances of you returning to that particular fast food restaurant is very small. So they may have lost a customer forever as a result of that, and they hardly even knew that they even had a quality problem. So we can see from this slide that in the United States, that at the end of World War II, the United States jobs in the United States were primarily in manufacturing. That is the line in red in this chart. And over the decades since the end of World War II, the number of manufacturing-related positions have decreased, and the number of service-related positions have increased. So in the United States, most jobs today are service-oriented. That is not to say that the United States is not involved in manufacturing. The United States is still one of the largest manufacturing countries in the world. But based upon total employment, the majority of our positions today are service-oriented. But remember, operations management applies to the service industry as well as it does the manufacturing industry. Now, operations and supply management is basically all about matching supplies against demands. As we said earlier, being able to predict the demand for an item is a very difficult thing to do. That is one of the sources of variability because customers change their mind from day to day, from hour to hour, on what and how many that they wish to buy. So operations is about producing or creating supplies that are going to be meeting demand. If our supply exceeds our demand, then our costs will increase. We have an excess of supply. Our profits will decrease as well. If supplies are less than demand, then we have lost a potential revenue. We may have had customers who were willing to buy, wanting to buy, but the availability of the product was not available. And so therefore they did not buy, and maybe they bought a competitor product, and we lost the revenue from that particular customer, and we may have lost that customer for life. So the only ideal situation is that supply be equal to demand. That is the ideal situation. From my years of experience in industry, it is very difficult to have a pure supply equal to demand equation. For the most part, the most normal situation that operations people work with is that supply is less than demand, and we're always trying to scurry about to try to get supplies to increase so that we can at least get it equal to demand. So from an operations management point of view, let's take a look at some of the things that they are responsible for. So operations management uses forecast. They do not create the forecast, but they use the forecast. That's very important. Make sure you realize that. The forecast is going to tell operations management what we think the demand will be. Also, they are responsible for capacity planning. We'll talk more about that later. But capacity planning is basically determining how many employees, how much equipment, how much space do we need in order to produce the product that we need to produce. Where the facilities should be and how should it be organized. How we go about scheduling. How do we go about determining the timing of when something needs to be done. The management of all the inventories is probably the most important function that operations management people need to do, as well as making sure that the quality of the product is meeting the customer expectations. So the operations manager consists of all those activities that are related to producing or providing those services, okay? And basically, we can take all the decisions that operations managers have to make and break them into two broad categories. One we'll refer to as system design decisions, and the other we will refer to as system operation decisions. And we'll talk about those two as well as other things in the second part of this lecture. So this concludes Part A of Chapter 1. Welcome back to Chapter 1, Introduction to Operations Management. This will be Part B of the lecture. So hopefully you have completed Part A, and we will continue along with the chapter. So we concluded Part A of the chapter by talking a little bit about all the decisions that operations management must make, falling into two broad categories, and they refer to as system decisions. So before we talk about them, let's talk a little bit about the systems approach. Let's define, first of all, what a system is. So a system is a set of interrelated parts that must work together for some overall purpose. So think of a typical automobile as being a system of interrelated parts. So what are the interrelated parts of an automobile? Well, you have an engine, you have a transmission, you have a rear end or differential, you have the passenger part of the car, you have the interior, the electronics. All these things must be working together. Well, the same concept applies to the business world as well. So we have marketing subsystems, we have operations subsystems, we have finance subsystems. And for each of these systems, the systems approach has us to look at the overall system holistically. Look at it as a whole, that the whole is greater than the sum of its parts. So operations people need to be looking at the operations system and to be looking at all the elements of the system working together for some common good. So system design decisions from an operations management perspective are those types of decisions that are involved from a very strategic point of view. So strategic decisions are typically decisions that are made that have a very long-term effect on the business. So for example, if we make a decision to build a particular plant in a particular city. When we make that decision, we're making a long-term commitment that we're going to build that plant, and we can't make that plant go away easily. Some of the other examples of system design decisions would be the overall capacity. How much equipment do we need? How many employees do we need? How are we going to organize the facility for a material flow perspective? The other kinds of decisions that operations management people are more from a operations or more from a tactical day-to-day point of view. These are the more common types of decisions that take place, okay? So how much inventory do I need? Remember the equations of supply and demand. Ideally, we want supplies to equal to demand. But that's a very rare occurrence that supplies are equal to demand. So every day, certain decisions have to be made in order to try to balance that. Do we have enough people? How are we scheduling? Okay, how's our quality? So why should you be interested in studying operations management? So there's a few good reasons shown on this slide, but I think there's a couple of other reasons that I would like to share with you that's not necessarily defined in your textbook. But operations are something that is involved in essentially every company. It's going to have some operations people because of the operations people that are going to be producing and creating the goods or the service. So how well those operations people perform their task has a great impact on the amount of customer service that you have, as well as the overall profitability of the business. Now, there's a couple of other reasons why I think that you should be interested in studying operations management. The first is that when you leave the university and you start your career, you're going to find that you're going to have multiple career paths. So if you're interested in studying accounting or finance or marketing and you feel like that you're going to be working in marketing or finance or accounting the entire career, most likely that's not going to happen. There will be situations that will occur, either of your choice or not from your choice, that will put you on a different career path. And you never know. You never know. You never know exactly what career path you might find to be your cup of tea and what it is that you love and do best. And maybe operations management is that career path that you've been looking for. There's another reason why you should be interested in studying operations management, and that is that most corporations today, when there are difficulties and problems to be solved, quite often management will identify a cross-functional team, which means that there are members from different departments to come together to study a problem or situation and come up with a solution to it. So even if you are in finance or marketing or accounting and you're part of a cross-functional team, there will be someone on that team who is from the operations department. And the more that you understand what they're responsible for, the more that you understand their vocabulary, the more that you understand what worries them, what keeps them up at night, the better that you'll be able to work in a cooperative team environment to solve the problem that you've been appointed to solve. So we have to make many decisions in operations management. That's one of the things that I have always enjoyed about operations management from my career in industry is that every day you're making decisions. And those decisions are going to have an impact on the overall success of the business. So some examples of some of the decisions that you're going to be making is How much material do we need? Where do we need to get the job done? Okay, what resources do we need? In other words, do we need certain types of employees? Do we need certain types of equipment? How are we going to get this design? And who's going to do the work? Who's going to be the supplier? Who is going to provide the materials that we're looking for? These and many, many other decisions are made by operations people every day. So, how do we go about making these decisions? Well, we have a number of tools available to us. One type of tool that we have available to us is to create a model. A model is, by definition, an abstraction of reality. In other words, it's not the real thing. It's something that's similar to the real thing, but it's not exactly the real thing. So there's certain things that we will leave out of the model, but the model needs to be realistic enough to give us a representation of that. A couple of examples of model. As a young boy, I can remember making models of cars, assembling models of airplanes. Those are representations of different physical things. In the automotive industry, I'm not sure if they are still doing this, but in the past, what they've done when introducing a new model automobile is they will have a highly skilled person create a life one-to-one model of the car, but in clay. So clay is easily molded, and so the model maker can make this life-size model of the car in clay, and different marketing and management people can look at the design, and they can easily change the design of the car by telling the model maker to take a little bit off of this part and add a little bit more over there, and they can see whether they like that or not. So modeling is an important part of our operations management toolkit. So we have different types of models. We have the physical models, which we just talked about before. Other types of models that we could have, we refer to as a schematic model. So a schematic model, it looks less like the real life model. So some examples of a schematic model would be an engineer, an electrical engineer will make a schematic diagram, a schematic model of an electrical circuit. And in the schematic model, he will have represented by different electronic components, different symbols that are connected together. We also have mathematical models. So this particular slide shows a very complex calculus mathematical model. So mathematical models, they certainly do not look like the real object that they're representing, but they help us to represent those elements that go into that model. So modeling has a lot of benefits. They are generally easier to use and they're less expensive. So going back to the clay, life-size clay model of a car, that's a lot less expensive to create that than it would be to create the physical car. And also in the process of creating the model, it forces us to kind of organize our thinking. So it helps the model maker think about the problem they're trying to solve because they're forced to think through all the elements that go into the model. So it gives us a better understanding of the problem that we're trying to solve. Models should be something that we could do some what-if analysis of. And I think a good example of a model that would lend itself to what-if types of question would be a model that we could create in Excel. So we could create a financial model in Excel, and we could embed within that Excel worksheet certain formulas, and then we could go in and see what would be the effect of if we changed this cost from this to this, or a certain interest rate from one to another and let the formulas calculate through to see what the result would be. So there's a great deal of benefits of modeling shown on this slide. So some examples of some of the quantitative models, some of the mathematical models that are involved in operations management is shown here. So linear programming is one we'll talk a little bit later in the course about. There is a chapter in linear programming in your textbook, but we will not include that in our syllabus this semester, but you're free to read through that if you'd like to. Some of the mathematical models that we will cover in some depth this semester is inventory models, as well as forecasting techniques, and also statistical models are things that we will cover and that you will also be tested on in the exams. Now we'll switch gears a little bit and talk a little bit about the historical evolution of operations management. And we'll go through these elements right here, starting with the Industrial Revolution. So prior to the Industrial Revolution, the Industrial Revolution was an 18th century activity that began. But prior to the Industrial Revolution, the production of goods was typically a craft in which very skilled workers, who in many cases had to start as apprentices, were able to build the product from start to finish. They took a great deal of pride in their work. Production was quite small at that time as far as volume were concerned, okay, and things were not quite as complex. But the Industrial Revolution came along, and the Industrial Revolution allowed humankind to be able to use machines in order to produce products and to be able to produce them in much greater volume and also reduce the cost of the product so that more people could afford to have them. So when the Industrial Revolution began in England, some other elements that are shown on this slide right here. So Eli Whitney, in his invention of the cotton gin, essentially transformed the cotton industry, where the removal of the cotton seeds had to be done manually, into a machine activity in which the productivity went up dramatically. But even though machines were taking more and more of the work, the management theories to be able to control the human element of the process really didn't catch up until much later, and we'll talk about that next. So Frederick W. Taylor, who as an industrial engineering student many years ago studied the works of Frederick W. Taylor. Frederick W. Taylor is considered to be the father of industrial engineering, and Frederick W. Taylor's contribution was to be able to take operations and to try to approach it from a scientific point of view, either from observation, from analysis, being able to take the work being done and break it down into all the individual elements that it took to do that, try to improve each of those elements, and then reassemble the improved elements into an overall improved process. The overall result of this was try to maximize the output and also reduce the overall cost of the production. Some other major contributors to the scientific management are shown on this slide here. So Frank Gilbreth and his wife Lillian Gilbreth, you may have heard the phrase cheaper by the dozen. Cheaper by the dozen, they had 12 children. And one of the things that Frank and Lillian Gilbreth contributed was the study of motion and time, to be able to do things with the minimum amount of physical activity. So the keyboard, the typewriter keyboard that we use today on essentially all computers, was designed by Frank and Lillian Gilbert. So they studied all the characters in the English alphabet and analyzed hundreds and thousands of words to see which letters are used most often and what was the most optimum configuration of laying out the letters on a keyboard for effective typing. And of course, Henry Ford in this slide is the inventor of the assembly line and mass production that we enjoy today. From a human relations movement point of view, we not only see Lillian Gilbert on here, but we see some other very important people. I hope that you're studying some of the works of these people in some of your other courses here at the university. These are not necessarily operations management topics, but they are very important for your overall understanding. So Abraham Maslow gave us the hierarchy of needs, where we have certain basic needs that we have that unless those are satisfied, that is our most important need. And once that is satisfied, then what is the next most important need? And once it is satisfied, what is the next most important need? Until finally, the last need on the list. We also have Hertzberg and McGregor, as well as other people who contributed to the human element or the human resources side of the equation. From a mathematical point of view, we have some models and some management science contributions by some of the individuals shown on this slide here. Now, we will be studying a few of these this semester. F.W. Harris gave us the mathematical models that we use in inventory management, and that goes back almost 100 years ago to 1915. Walter Shewhart is shown as the primary inventor of statistical process control and the mathematical models that he gave us. And we'll talk a little bit about George Dancing and his linear programming models that he gave us in linear programming. The Japanese have also influenced to a significant amount the way in which operations management is done today, beginning with the quality revolution that took place in the 1970s and the 1980s, beginning in Japan and then eventually going all over the world. And finally, just-in-time production. So we will be studying in separate chapters this semester the concept of total quality management, which originated in Japan, as well as just-in-time, as well as lean, which also was begun in Japan. So we'll kind of end Chapter 1 talking about some major issues from an operations management point of view. Okay. So economic conditions. Well, we live in a global economy. We've lived in a global economy for some time now. That's not going away anytime soon. So manufacturers in the United States depend upon countries in the low-cost countries, China, as well as other low-cost countries for delivering the components that are needed for their products. Innovation of products is a constant challenge. The management of quality is a constant challenge. But let me say this about quality. Quality is an element today in operations that just gets you in the ball game to compete. If you have excellent quality, that's great, but that does not ensure that your product is going to survive in the marketplace. And the reason is because all your competitors have excellent quality too. It just gets you in the ball game. You're going to have to compete on something else other than quality. So, in addition to those concerns, we want to be environmentally friendly. We refer to that as sustainability. So from an operations management perspective, we want to do things in such a manner in the production and the creation of our products and services that does not damage our planet, does not damage our environment. This includes the use of materials that will not be damaging. It includes the use of processes that does not damage the environment, and also the effective way of destroying a product. Eventually, every product is going to wear out. It has to be disposed of, and a way of disposing of the product in a way that is not harmful to our environment. There's also some ethical issues in operations that we will study throughout the semester. Starting with worker safety. Whatever we do in our operations, we have to ensure that it's not going to be damaging to our employees, and our product safety, so that we will have a product that is not going to inflict any type of injury or harm on any of our customers. Other ethical issues involved quality. If we know that there is a quality issue, we are bound from an ethical point of view to identify that problem to people who have the ability and the authority to make corrective action, all the way to workers' rights and closing facilities. If for some reason we have to close a facility, there are certain ethical issues, and there are also certain legal issues in which we must abide by in order to do that. From a supply chain management perspective, we'll study this more in our chapter in supply chain management later in the semester, but there's different needs that we have to do there that are shown on this slide here. I'm not going to go into this slide in much detail because we're going to cover it in greater depth when we get to the chapter on supply chain management. So this slide also shows different issues in supply chain. So I'm not going to go through this in any depth because we will be talking about this later in the semester. And finally, this slide right here, the same comment. This concludes Part B of Chapter 1. Welcome to Unit 2, Chapter 2. These are the learning objectives for this chapter. You may want to pause the recording and review the objectives, but basically this is another overview chapter. And in this chapter, we'll be looking at 3 topics. We will be looking at competitiveness. We will also be looking at strategy. And finally, we will be looking at productivity. Well, as a business professor, what we're trying to do is to prepare you for the business world. And it's a cold, hard fact that business excellence is a journey. It's never a destination. That the best companies are going to be working to continuously improve their operations. So everything we talk about here is aimed at getting better. So what we'll look at in this chapter, as I said before, are 3 things. We'll be looking at the concept of competitiveness as well as strategies, especially operation strategies, and then finally productivity. So let's start with competitiveness. So this is the definition of competitiveness shown on the screen. So it's basically how effectively an organization will meet the needs and the wants of their customers relative to other companies that are providing the same product or service. So you'll recall from Lecture 1, we introduced Professor DeLuke's 3 fundamentals. And the first of his 3 fundamentals is to know your customer, or customer knowledge. So competitiveness is directly related to this. I ask you to think about an industry in the United States that for the last number of years has been very poor in competitiveness. And if you think about that, what industry will come to mind is the automotive industry. So for the last 20 years or so, the automotive industry in the United States has been suffering from a loss of market share. And one of the reasons is that their competitiveness has been low. I'm happy to report that the auto industry in the United States is making a turnaround. Their competitiveness is improving, and they are on their way back to competing as they did once before. So the marketing function within an organization has, among other things, the responsibility for understanding our customers' needs and our customers' wants, and what they're willing, the price that they're willing to pay. Now, the second thing we need to do is to identify those needs and wants and identify which processes within our business are going to provide our customers the things that they are seeking. So a company can compete on a number of different ways, as shown in this slide. So product and service design. I ask you to pause the recording and think about a company in the United States who has done an excellent job in competing based upon product and service design. The company that you most likely thought of is Apple. Apple's products are considered by most people to be superior in the design. I ask you to think about another U.S. company that has been very effective in competing based upon cost or based upon price to the customer. The company that you most likely have thought of in this example is Walmart. So their everyday low price policy has put them at the top of the retail industry. Think about a company that competes based upon location. When I say location, I'm talking about the frequency of location, that you don't have to go very far to be able to find one of their locations. And companies that you might think about in that area, one would be McDonald's. You don't have to drive very far in any direction on any road without running into a McDonald's. And another would be Starbucks, especially in those communities that have a higher per capita. There are Starbucks that are frequently located. But you'll also notice on this slide that we have some other areas that companies can compete in that are related to our primary topic, operations management. And those would be inventory management and supply chain management. You'll notice that the last item on this list has to do with employees, managers, and workers. Companies that compete based upon the skill and the knowledge and the motivation of their employees are very difficult competitors to compete against. Many of the other things on this list may require technology, and technology is something that can be purchased by any company. But employee skill and employee knowledge is something that you just can't buy in the open market. So that's always a good one that companies should try to work toward. Now, this next slide here shows a list of why companies fail. Well, there are literally hundreds of reasons why companies fail. But I ask you to take a look at this and take a look at some of the items on it. You'll notice that at the bottom of the list is a failure to consider customer wants and needs. You may know what your customer wants and needs today, and you may be meeting those, but in any given year, those wants and those needs may change. So if you do not adapt to those wants and needs accordingly, then you're going to be in a difficult situation. We'll move to the second topic in our 3 topics in this particular chapter, and that is hierarchical planning. So the word hierarchical indicates that there is a subdivision. In other words, we could have, similar to an organization structure, you have a CEO, and reporting to the CEO, you have various different vice president levels. So even though the diagram in this slide just shows a linear path, in actuality, this is a hierarchical. And it shows that there is a linkage between each of these elements, the mission, the goals or objectives. So both of those words could be used. Organizational strategies, functional strategies, and then finally tactics within those. So let's take a look at each of these levels of the hierarchical structure and talk a little bit about what they're all about. Beginning with an organizational mission. So the mission of a company is the reason why an organization exists. So this is something that every company needs to think very carefully about. Why are we in business? What is the purpose of our existence? The goals or the objectives provide a little bit more definition into the mission statement. And then the strategies provide a structured approach in which the company will compete in their particular marketplace. So again, the mission, the reason for the organization's existence. Typically, the mission statement is very broad in nature. It does not go into a lot of specifics. For example, the mission statement is generally not going to define what particular products or services that the company will be providing to their prospective customers, but just talk a little bit about what it is that they're trying to do. Here's an example of a mission statement for FedEx Corporation. Now, we all know what FedEx does. It's provide excellent delivery service for packages and all kinds of things. So you may want to pause the lecture at this point and read through the FedEx mission statement. You will see that it is very high level in nature. It talks about different standards that they want to meet, but it doesn't provide any particular specifics as to how they're going to go about meeting the mission statement. The goals are the objectives. So this is going to provide more detail as to how the corporation is going to be meeting the goals and the objectives. So within a corporation, a company is going to have usually more than one goal or objective, but not a great number of them. So there will be one mission statement, but there could be maybe 2 to 3 goals or objective statements. And these objective statements generally do not change very much in time. However, depending upon the circumstances, depending upon the market conditions, a corporation may go back and review their objectives and revise the objectives slightly, or they may add an additional objective, especially if they see a new business opportunity opening up in this particular area. But generally, goals and objectives are not something that's going to be changing very much once they have been set by the executives. And of course, it's the executives of the corporations that typically are involved with the definition of the mission and the goals and the objective. So for each goal and objective, the company will define what strategy that they will be using. So if you take a look at the slide says that the strategy serves as a roadmap. Well, yes, it certainly does that. Let me give you my own personal definition of the word strategy. My own personal definition of the word strategy is that it is a structured approach to compete, a structured approach to compete. So the word structure indicates that it is a concept, it is a plan that is the result of a great deal of analysis. Strategies are not something that are very quickly determined. It takes a great deal of time and work to be able to define what the strategies are. And we can have different types of strategies. So you'll see in this particular slide that we can have organizational strategies. So organizational strategies would be strategies for the entire corporation. And then we could have supporting functional level strategies. So a particular functional strategy could be a strategy for the operations management. So what strategies will the operations management organization use that are going to be supporting the organizational strategy? There could also be functional strategies that are defined for the marketing function or for the finance and accounting function. All of these should be supporting the organizational structure. Now, one of the difficulties in the functional strategies is that it's been my personal experience that many times the functional strategies, where they ideally should align with the organizational structure, they may be defined in such a way that they optimize that particular functional area, such as accounting or marketing or operations. And in effect, the functional strategies may not coordinate or work completely together. So this causes some difficulty for a company. It's always a challenge to get those functional strategies aligned so that they are truly working in a harmonious way. Now, for each strategy, there will be tactics. So the tactics are the short-term actions that are necessary for a particular functional group to carry out in order to meet their overall strategy. So these are the short-term things that may be a project that lasts for 3 months or 6 months or possibly a year. To implement a new information system could be an example of a tactic, or to implement just in time or something of that nature. So strategies are supported by various tactics. Remember that these are hierarchical in nature. Let's talk a little bit about core competencies. So when we define our strategies, one of the things that we need to understand is what are the core competencies within our functional department or within our company. So the definition of a core competency, it is a special attribute or ability that organization has that enables it to compete. So let's take an example. Let's say that you are an athlete and you have a strategy for your particular team for competing with other teams. Well, what core competencies does your team have that enables it to compete? Well, perhaps one of the core competencies that your team may have is overall team speed. So in many sports, the faster athletes tend to be the better athletes. So we have fast athletes on our team, and so we're going to use that team speed as a basis for our strategy for competing. I'd like to give you some examples of some core competencies in some of the companies that I have worked for in my career. I started my career with Texas Instruments Corporation, and I think that the core competency there and continues to be at Texas Instruments innovativeness. So the ability of its engineers to innovate was the core competency. I worked for Electronic Data Systems, EDS, which is now part of the Hewlett-Packard Corporation. And the core competency that I observed for that corporation was customer service. So there was an extremely strong desire and ability to meet customers' needs. So those are a couple of examples of core competencies. This slide shows a few examples of some operations strategies that a corporation could have. So we could have a strategy, an organizational strategy for having the lowest price within our industry. And of course, if we're going to have low prices, what we need to have is we need to have low costs. So our operations organization needs to make sure that our production costs as well as our other support costs are as low as they possibly are. So take a look at some of the items on this particular slide. I'm not going to go through each one of them, and you can see the organizational strategy that could be there and what the supporting operational strategy could be that supports that organizational strategy. And then finally, some companies over on the right-hand side that have excelled at this particular area. So how do we go about coming up with a strategy? How do we go about coming up with a structured approach to competing? Well, we need to identify what our core competencies are. So as I mentioned before, if we were an athletic team and if one of our core competencies was team speed, that was something that we need to employ in our strategy for competing. In addition to that, we need to do what your textbook is referred to as environmental scanning, but really another way of describing environmental scanning is internal analysis or analysis of different things. And one of the most commonly used ways of analyzing an organization or a company is with the SWOT methodology. Each letter of the four-letter acronym SWOT stands for a different word. S stands for strength, W stands for weakness, O stands for organization, and T stands for threat. And I'm sure in your marketing courses that you'll take out here, you'll also study the SWOT method. So the strengths and the weaknesses, those are forcing a company to look internal to itself. What are we good at? What are we not so good at? Opportunities and threats. Opportunities and threats force a corporation to think external, to look outside of the company and look at what is going on out there. We also need to take a look at some other things we'll talk about in upcoming slides here, as far as order qualifiers and order winners. So, order qualifiers. So when we say the word order, we're talking about winning our customer's business, winning the order from our customer, winning some type of a sales activity for them. So order qualifiers are those things that our customer just expects as a bare minimum. If you don't even have these particular things, you're not even going to be considered as a potential provider of the products or the services that you provide. Order winners, for example, are those characteristics of our products and our services that our customers perceive that, hey, that's better than anybody else. I really like that. That's something that I really want to have. So let me give you an example of the difference between order qualifiers and order winners. So if you're planning a trip to a destination and you're going to be flying by air, you're going to be looking at different air carriers to get you to your destination. Well, what are the qualifiers that a company, a air carrier will have? Well, it has a direct flight from where you're wanting to go to where your destination is. But there is, there's several airlines that have a direct flight. So that's just kind of a minimum thing that the company needs to have in order for you to consider choosing them as your air carrier. Order winners, however, could be things such as onboard entertainment. So one particular air carrier may have better onboard entertainment, the ability to have various movies that you could watch on the seat back in front of you, or there could be other perks in that particular space, such as a more comfortable seat or maybe greater leg room in that enables that particular airline to actually win your business for that particular trip. So the environmental scanning, the looking at internal factors, the strengths and the weaknesses, that's the first part of SWOT. What are we good at? What are we maybe not so good at? So we want to emphasize our strengths and maybe try to minimize our weaknesses to the best we possibly can. External factors are the opportunities. So in every market, there's always changes taking place. What are the new opportunities that are going to be coming available in our market? And then threats. And threats can come in various forms. They could come with potential new competition to enter the market that's not there today. Threats could also come in the form of economic threats, such as recessions, or they could come in the form of government regulation, which could increase our costs. So these are things that we need to consider as part of our SWOT analysis. Now, before we go to the next slide, let's kind of take the SWOT concept, strengths, weaknesses, opportunities, and threats. Let's kind of relate it to a student on a personal level. So for some of you, the time for your graduation may be approaching. It may be this semester, or it may be in the next semester, or maybe 2 semesters after that. So in order for you to find the ideal job that you may be looking for, you need to have a strategy for how you're going to compete in the job market. What is your SWOT? What is your strategy? And your strategy should be based upon your personal strengths and weaknesses. And it also should be based upon opportunities for the particular area of work that you're wanting to pursue, as well as other threats, such as other competition from other students as well. So these concepts that we talk about in the class can also be applied to your personal life as well. So I encourage you to think about those as we go through these. Other things that need to take into consideration, of course, are the overall economy. Is the economy growing? Are we not growing? The political conditions in election years. Quite often, these influence strategies, and corporations may want to be more conservative during election years until they know which particular candidate or which particular party may be more likely to win office. The legal environment, legislation, technology is always changing quite often. Technology may open doors to new markets and new opportunities that were not there before. We know that competition is ever increasing. We live in a global economy, and competition can pop up just about anywhere, as well as new markets. And And one of the newest markets that we see, especially in the area of consumer electronics, is the tablets market. So several years ago, Apple introduced the initial iPad, and what that has opened the door for is the market for literally many companies to enter the tablet market and compete in that particular business. Internal factors we need to consider as part of our overall strategy would be our employees themselves. Do our employees have the skills that we need to be able to compete in this particular area? The equipment and the facilities, financial resources, especially the ability to borrow money. So quite often competition is dependent upon technology, and technology is expensive, and we have to be able to get a loan in order to be able to do these things. Of course, customers and products and all these other things shown on this slide as well are also internal factors, things that we have some level of control over in order to compete well in this area. This concludes Part A of Chapter 2. Be sure to view Part B at your earliest convenience. Welcome to Part B of Unit 2 on Chapter 2. So in Unit 1, or Part A of this chapter, we took a look at competitiveness, and we started our path in talking about strategy, a structured approach to compete. And what we're going to be doing in Part B is continuing our journey on strategy, except starting to focus more on the operations strategies, which are the strategies that we will discuss in our course this semester, and then finish this chapter with a discussion of productivity. So, operation strategies are shown as examples in this slide right here. So, operation strategies such as competing based upon cost, competing based upon quality, competing based upon location, all of these things are options that a corporation has for defining how they will compete from a operations point of view. You'll notice that supply chain is also shown on this diagram. So for many companies, they compete based upon the effectiveness of their supply chain. Companies compete based upon quality. So we can choose quality as the basis for this. Now, as I've said in Chapter 1, and you'll hear me say this again in other chapters, competing based upon quality is becoming more and more difficult to do because most companies have reached a level of parity in quality with their other competitors. So it's very difficult for a company to really try to differentiate its products or its services purely based upon quality. But of course, you need to remind your customers, if you have a reputation for good quality, that you continue to emphasize that and remind them that your quality is still at the level that it has always been, which meets their expectations. We also can compete operationally based upon time. So when we talk about time-based strategies, we're talking about whatever product it is that we're producing, doing it faster, reducing the time it takes to produce our product, reducing the time it takes to get new products to market. There is a direct correlation between time and cost. So anytime we're able to do things faster, generally the cost will go down. So in the business world, when you graduate, If you can't think of anything to improve, you can always reduce the amount of time it takes to do it. Now, there's one exception to that. Time-based strategies of reducing the time it takes to do something are good as long as it does not impact the quality. So getting fast at the expense of reducing quality is going to have an overall negative effect. But we should always be trying to reduce time if we possibly can. Here's some examples of some time-based strategies. Planning time. How long does it take for us to plan our activities? Now, you wouldn't think that planning time is very long, but actually in many corporations, planning time can be extremely long. So being able to plan more quickly without compromising the quality of the plan is something that we could work upon. Product service design time. So for many companies, especially in the automotive industry, one of the biggest success factors of Toyota Corporation has always been their ability to introduce a new car into the market faster than their United States counterparts. So their ability to design a car, test it, and get it to market faster has always given them a competitive edge. Processing time, delivery time, reducing the time it takes to handle customer complaints or customer issues are also things that we could work upon from a time end. Another operations strategy that we could employ is being agile. The definition of being agile is the ability of changing quickly, adapting quickly to market changes. This is especially true, especially in the consumer electronics industry. Some examples of some consumer electronics products where agility is very, very important is in the cell phone products. So we saw several years ago, Apple introduced the first iPhone. And when they introduced the iPhone, it just totally changed the dynamics of the cell phone industry. So all the other competitors in this industry that did not have a touchscreen smartphone that could compete with Apple, they had to very quickly be able to change and adapt to get new products designed that are at that particular level and to get them to market quickly. So agility is another area that we could compete in from an operational perspective. Now, in Chapter 1, we talked a little bit about Professor DeLuke's 3 fundamentals, and the third fundamental is measurement. So starting with this slide right here, we'll talk a little bit about the concept of a balanced scorecard approach. So we need to continuously improve, and the way that we know whether we are improving or not is through some measurement. The balanced scorecard approach was first introduced back in 1992 by Robert Kaplan in a Harvard Business Review article that he wrote titled Balanced Scorecard. You may want to do a Google search on Balanced Scorecard or Robert Kaplan, Kaplan, and take a look at his paper that he wrote in the Harvard Business Review. But basically, the approach that he espoused was that when we measure things, we need to have a balance, that any particular measurement that we may take is only looking at the issue from one dimension. And that one dimension, we can get a distorted view if we only look at one particular thing. But if we look at several dimensions of an issue. We get more of a balanced view. And some of the dimensions that he suggested in his paper was a measurement where we're looking at things financially, from a financial point of view, and one from a customer point of view. How well are we meeting the customer's needs? And one from a business process point of view, and one from an employee point of view, a learning and growth. And if we have several measurements that are looking at the thing we're trying to measure from different points of view, it gives us more of a balanced point of view than looking them at just one and only one particular measurement. So the balanced scorecard could have some financial measures, could have some customer measures. How well are we meeting customer needs? So from a customer need point of view, a measure that we could have is on-time delivery performance. So how well are we delivering orders to customers on the date or before that they are wanting them? Financial, are we meeting our particular cost objectives? Internal process measures. An internal process measure could be a quality measure, for example. We have internal quality processes. So are we hitting our quality measurements that we're looking for? And then also learning and growth. We could have a measure for our individual employees. Are they achieving certain internal certifications, for example, as well? Now let's take this balanced scorecard concept and let's apply it to a typical university student. What are the measures that we have for a typical university student? Well, the most common measure that we have for a university student is grade point average. But grade point average really only measures one particular aspect of a university student's life. Are there other things that we could measure besides grade point average? The answer is yes. We could measure the students' involvement in the community. We could measure students' involvement in service organizations within the university as well as other things. So we can take this concept of a balanced scorecard and we could also apply it to a university student as well. We'll now begin the third and the final part of our topic in this chapter, and that is productivity. So productivity is a measure. Productivity is a measure that we could possibly include in our balanced scorecard. It is a measure that basically measures how well we use our resources to achieve whatever goal we're trying to achieve. So productivity is a very commonly used measurement for operations management. And productivity as a formula would be the ratio of the output divided by the input. So P is equal to the output as the numerator divided by the input, which is the denominator. So in other words, what did we produce and what was required in order to be able to produce it? So productivity is commonly used. Now, if we go back and we think about the life of a university student, and if we think about the most common measure that we have for a university student, and that would be a student's grade point average. And if we look at the grade point average, we will see that the grade point average is basically a productivity measure, is what it is. So the output of any given semester is your semester hours earned, your grade point earned, semester hours attempted, multiplied by the letter grade that you made in that particular course. So if you took a 3-hour course and you made an A, then you had an output of 12 grade points for that particular course, divided by the input, and the input was the semester hours that were attempted. So for that one course, it was a 3-hour course, so you earned 12 grade points divided by 3, and that is a ratio of 4. So grade point average is basically the basic productivity measure for a university student. So productivity is very important for a number of reasons. Not only does it tell us how effectively we utilize our resources to get a job done, but productivity can also be measured at a national level, the United States or any other industrialized country. And the United States Department of Commerce is responsible for measuring the productivity within the United States. Productivity is directly linked to standards of living. So if productivity is increasing within the United States or within any other country, it means that our standard of living is improving. What that means is that you and I are able to afford the products and the services that we wish to purchase at a reasonable cost. And as productivity increases, it also means that we can keep the price or the cost of our products fairly stable, while at the same time giving higher wages or raises to our employees. So productivity at a national level is something that's very important for all of us. Now, productivity is going to vary from industry to industry. Certain industries, by their very nature, are going to be more productive and have a higher productivity as opposed to other industries. Now, this slide shows several ways in which we can measure productivity. So you'll notice that at the top of the slide is our primary formula, that productivity is equal to the output divided by the input. So we could also have productivity defined using partial measures and also multi-factor measures. Now, the difference between a partial measure and a multi-factor measure is in the denominator of the ratio. A partial measure will have only one element in the denominator. For example, if we have a productivity measure of output divided by labor. So we produced 100 units, that is the output. The labor is the number of hours that were required in order to produce that. So let's say that it took 20 hours of labor to produce those 100 units. So 100 divided by 20, that productivity partial measure would be 5. In a multi-factor productivity measure, we may want to include in the denominator several factors. So let's say, for example, we wanted to include not only the labor that was necessary to produce the output, but also how much machine time was required as well. So for any particular company, they can choose to decide what are those elements that are important to us to consider in this productivity measure. And then you'll notice that in the last part of this slide, we see a measure, total measure, goods or services produced divided by all items used to produce them. That's the productivity measure at a national level. That is the way in which the United States calculates the productivity of the United States. What were the goods, the total value of all the goods and all the services that were produced by every company in the United States? And then, what were the inputs that were required in order to produce those goods or those services? Here's an example of a multi-factor productivity measure, and what I will also include as a learning aid, I will have a whiteboard session. We'll go through some other calculations for productivity measures. You should expect on your exam for this chapter to have several problems in which you will be required to calculate productivity measures. So in this example shown on this slide, we produced 5,000 units, and the selling price for those units was $30 per unit. What was required in order to produce those 5,000 units was 500 labor hours. The cost of each labor hour was $25. We also had some material costs that were involved, and that value was $5,000. And we have some overhead costs, and our accounting department has told us that our overhead costs are essentially twice our labor costs. So what would be the multi-factor productivity for this given set of data? So to solve that equation, the multi-factor productivity is the output divided by the labor plus the material plus the overhead. Of course, material, labor, and overhead is going to be your total cost. So the output is we produced 5,000 units, and each unit had a value of $30 each. So essentially, we're converting the output to a revenue measure. So 5,000 units times a selling price of $30 gives us a revenue of $150,000. We had a labor of 500 hours times $25 an hour. Material cost was $5,000, and our overhead cost was twice the labor cost, so twice the 500 hours times $25 an hour. So our input cost was $42,500. The ratio of those two numbers was 3.5. So that is our multi-factor productivity. Now don't worry about that question at the bottom of the slide, the implication of a unitless measure of productivity. That's not important. Don't worry about it. This slide shows the trend of productivity in the United States going back to the mid-1970s. You can generally see that it has been on an upward trend, but there are little changes to it. If you take a look at some of the specific numbers, let's look at, for example, try to look at the year 1990. 1990 and 1991 were recessions in the United States. And so productivity at the beginning, the very, very beginning of a recession, is going to typically fall off a little bit. But if you look at the graph starting around the year 1993, you'll notice that there is a very significant change in the slope of that graph. So what happens in a recession? Well, what happens in a recession is that revenues fall for companies, and as a result of that, companies will lay off employees. And very quickly after they lay off employees, productivity increases. I know that sounds strange, but productivity actually increases. Why does it increase? Because they're typically able to produce as much or more than what they were before. So the output could be the same, or it could go down a little bit, but the input, the amount of labor that was required to produce that, goes down significantly large. Input goes down significantly large because there's much fewer employees. And the result of that is that productivity increases. If you take a look at the year 2000, that was the end of the dot-com bubble in the United States. And you'll notice that productivity was flat for a couple of years, but then it really took off again around the year 2005. Again, the same thing. We had a recession at the end of the dot-com bubble, so massive layoffs, and then productivity increased greatly. Just so happened to notice that in today's newspaper, the Dallas Morning News, that there was a report of productivity, and productivity is starting to fall. And actually, that's a good sign in this case. So at a certain point, productivity during recessions, productivity increases. But as we come out of a recession and as the economy starts to grow, that we reach a certain point where corporations are not able to maintain that same productivity as demand starts to increase again due to the growth. And productivity will start to fall a little bit. And that's the point where hiring really starts to pick up again. And hopefully this is a good sign for a lot of unemployed people, that drop in productivity is going to indicate a resurgence of hiring. This slide shows the formula for calculating productivity growth. So any one particular productivity measure doesn't really tell us very much. It's only when we have several productivity measures and we can compare them to see whether productivity is growing or changing over time that is important to us. So the formula for productivity growth is defined to be the current productivity minus the previous productivity divided by the previous productivity, and then multiplying that ratio times 100%. So what you're essentially doing is taking the ratio of two numbers and converting it into a percentage by multiplying it times 100. So in this example here, the previous productivity was 23 units per hour, and in the current year, that increased to 25 units per hour. So inserting those values into the formula, we have the most current productivity of 25 minus 23 divided by 23, and then multiply that times 100, so productivity increased by 8%. Now, there's another way that we could get exactly the same value of 8%, which to me is a simpler way to do it, and that would be just to simply divide the current productivity by the previous productivity. 25 divided by 3 is 1.08, or essentially saying that we improved by 8%. The 1.08 is an 8% increase. So it doesn't really matter which formula you use, you're going to get exactly the same answer. And you can expect in the first exam to see at least one problem on the exam where you will have to calculate the productivity growth. Productivity in the service industry is typically more difficult to measure than it is for a company that produces a product or service. And this is for a number of reasons. Let me give you an example of productivity in the service industry that is typically difficult to measure and is also typically very low. and that would be the construction industry. So when you walk around our campus, you may see that we have construction going on, we have new buildings going on. Every now and then, just stop and take a look at what you observe in the employees that are working on that particular construction project. And the service construction productivity is typically low. And the reason why it's low is for a number of reasons. One is the things that they are doing in any particular day changes from day to day. You know, they're not doing the same thing. And also, in order for a crew of construction workers to be able to do something, there may be some other activity that had to be completed before they can do their work. And maybe that activity is not yet completed. So they can't do their work until the previous work has been done. And so they're kind of idle while they're doing that. So service productivity is more difficult to measure, and typically it's lower than productivity where we're producing goods or services. So what affects productivity? Well, there's a number of things that affect productivity shown in this slide. The most biggest factor that affects productivity is the box in the lower right-hand corner, and that's management. So the way management approaches productivity and their investment in human capital and their investment in technology will greatly affect the overall productivity. In addition to that, the procedures and the methods that we used affects productivity. Whether or not our quality is good or bad affects productivity. If our quality is not good, that means that we are having to do rework to fix things, or we're having to scrap things that cannot be reworked. And so forth, the output is reduced. Technology has a big factor in productivity. And how much investment that we make in capital also affects productivity. So how do we improve productivity? Well, there's a number of ways that we improve productivity. Define what our productivity measures are is the first step. Also, if we're producing a product and we have a series of steps that we go through to produce that product, quite often there is one particular step that tends to be a bottleneck. It tends to be a constraint. It tends to control the overall output of that particular product. So know what your bottlenecks are and try to reduce those bottlenecks as much as we possibly can. Make sure we have a method for improving productivity. So how do we go about defining what our process improvements are? Establish some reasonable goals for productivity improvement. So what is our productivity today, and what would we like for it to be at some future date? Make it clear to employees that we expect productivity to improve, and we encourage employees to come up with ideas and suggestions on how we want to improve that. And then finally, publicize improvements. So as we achieve success in productivity, make sure that we celebrate those successes. We give recognition to employees who have done well in those particular areas. This concludes Part B of Chapter 2 and Unit 2 on productivity and competitiveness and strategy. Welcome to Unit 3 on Chapter 3 on forecasting. This is the first of our really significant chapters related to operations management. This slide shows the learning objectives for this chapter. You may want to pause the recording and review the objectives and then continue when you're finished with that. So, what is a forecast? A forecast is a statement. Another way of saying that is it is a prediction. So it is a statement or it is a prediction about the future value of a variable of interest. Now, it's hard to pick up a newspaper any day and not find an article on something that's being forecasted. Literally everything is forecasted. But from an operations management point of view, the variable of interest that we are most interested in is what will be the demand for our products, because operations people are responsible for the production, the creation of those products, so we have to have an idea of how many are going to be needed. Now, as a reminder, forecasts are used by the operations management people, but operations management do not create the forecast. The forecast is created usually by the sales department. The marketing department may also be involved. The accounting department may also be involved, but of course they're typically going to be forecasting financial information as well. Now, as the slide shows, the last sentence, forecasting is both an art and a science. In this chapter, I will attempt to teach you some of the science of forecasting, some of the mathematics of forecasting. I can certainly do that, and you can certainly learn that. But the art part of forecasting is something that neither I nor anyone else can teach you. The art of forecasting is the experience that goes along with forecasting. So if you have a number of years of experience in a particular area, you have a general feel for the demand, the market conditions, what's going on. So good forecasting not only involves the mathematics, but it also involves using your experience, your intuition as to what you think is going to be happening, and if necessary, overriding the mathematics part and going with your gut feel if you feel strongly enough about that. So we're interested from an operations management is what is the level of demand? Again, because we are going to be responsible for producing the product. And we need to create again, the operations people are not creating the forecast, but whoever is creating the forecast, hopefully that forecast has some good accuracy related to that. So when we talk about the accuracy of the forecast, we're talking about the potential size of the error that is associated with that forecast. Now, there are some common elements of forecasts. Sometimes these are referred to as the absolutes of forecasting. So the absolutes are that the future, the prediction of the future is generally going to be related to something that has happened in the past. That is generally true, but not always true. There's always exceptions to everything. But if we know what happens in the past, especially the most recent past, that should give us an indication of what's going to be happening in the future. Forecasts are not perfect. That's a very kind way of saying that forecasts are always wrong. That's right. Forecasts are always wrong. 100% of the time, they're always wrong. The only thing we don't know is whether they are too high or they're too low, or are they by how much they may be too high or they too low. Number 3, forecasts are more accurate when we forecast in groups of items as opposed to individual items. So, for example, if we have a product family of products and I forecast at a product family or product group level, I tend to be more accurate in those forecasting. And number 4, finally, forecasting accuracy decreases as the forecast goes out in time. So that usually the most accurate forecast is the most recent future time period we are forecasting, and the least accurate is the furthest time period in the future that we are forecasting. So if you watch television or radio, all the weather forecasters, they always make a 5-day weather prediction. It's a forecast. Which of the 5 days is generally the most accurate? And that is today. It's generally the most accurate. And the one that's least accurate is the 5th day in the forecast. So the elements of a good forecast are shown on this slide. It needs to be timely, accurate, reliable, expressed in meaningful units. It needs to be in writing. It needs to be simple to understand, and it needs to be cost effective. Let's talk about a few of these items. It needs to be timely. What I mean by that is if the demand is going to increase significantly, you need to give me time, operations management. If the demand is going to increase, don't tell me today that next month the demand is going to double. I don't have enough time to be able to adjust to that radical change in demand. I don't have the capacity. I'm not ready for that. So you need to forecast far enough in advance where people have adequate time to make adjustments. Of course, it needs to be as accurate as possible. Now, we said that forecasts are always wrong. That's true. But they can be sometimes fairly accurate, and that's what we're trying to do. They need to be reliable. It's better to be consistently wrong by a certain amount than to be very good 1 month in the forecast and very bad in the other. They need to be in writing. Verbal forecasts are just not good, and the time it takes to create the forecast and the cost associated with creating that forecast needs to be reasonable. So what are the steps involved in creating a forecast? First is determine what is the purpose of the forecast. Now, there could be a number of different reasons why we create forecasts. From an operations management point of view, we want to create forecasts primarily for 2 reasons. One is so we could plan what materials are going to be needed, but also to plan for our capacities, to plan for our workforce. Do we have enough workforce to be able to meet the demand? Do we have enough equipment? Those are the 2 primary reasons. There could be other reasons why we may want to do a forecast. They could be pure financial in nature. So the accounting department may want to do a forecast just to make sure that in the upcoming quarterly financial reports that the financial estimates are going to be hit. Establish the time horizon. So I'm going to be forecasting in the future. So how far in the future am I going to be forecasting? Am I going to be forecasting for 6 months, a year, whatever? I need to have some type of appropriate data. So the data that I am going to need to do the forecast is some historical data. So what has happened in the past? And this data needs to be, the word clean is referring to the accuracy of this historical data. Now, from my work experience, I can tell you with certainty that in implementing a forecasting process, typically getting good, clean historical data is usually a very large problem, a very big problem, because there have been so many mistakes that have been entered into the computer files on what has happened in the past. And if we don't have some way of going back and fixing those mistakes, then if we try to create a new forecast based upon data that is inaccurate, then what other result can we have but to have an inaccurate forecast? We need to select what forecasting technique we will use, and we'll talk about some of the ways to do that and what some of the techniques are. Create the forecast, and then we need to monitor the forecast. So we had predicted the next months of activity. So when that month is over, let's go back and look at what actually happened compared to what we had predicted. And we know there's going to be some error. So is there anything that we could learn from that so that the next forecast will be better? So forecasters, we want to minimize our forecast errors. So it's a very difficult thing to do, but it's something that if we work hard toward, we can improve on that. So the way that we measure the accuracy of a forecast is with a parameter we refer to as forecast error. And the formula that your textbook uses for the calculation of forecast error is what actually happened, what was the actual demand, minus what our forecast was for that particular time period. Now, this slide shows how we go about measuring the forecast accuracy. So let's take a look at the graph and let's observe that there is a vertical bar that's labeled today. So, and to the right of that, we see a green graph, and that represents our forecast. So we're always forecasting into the future. So that's today, and that is the future, and that's what our forecast is. Now, everything, all the data to the left of that vertical line that says today is what has happened in the past. That is history. That's water under the bridge, as they say. So if you take a look at the far left, you see some yellow lines and some dots, and that we refer to that as the initialization period. So that is our actual history back in time. And then we have a middle section with a red graph. The middle section is referred to as the ex-post forecast. Ex-post forecast. And what that means is, again, this is history. This is in the past. You'll notice that this area of the graph is to the left of the today mark. So it's in the past. And what the red represents is for a particular forecasting technique, whatever forecasting technique that we used to predict that green future. If we had used that same forecasting technique, that is what the red line would have been. So in other words, this is what we would have forecast with this technique had we used this in the past. So now that we know what we would have forecast in the past, and we can compare that to what actually occurred. So the little black square dots is the actual historical data. So in this ex-post forecast area, I can look at the error, and the error is the difference, the height between the red line and the little black dot. That is the error. So if I know what the error was in the past, I'm going to make a leap of faith. A leap of faith that that same error that existed in the past in that ex-post forecast portion will be the same as what it is in the future. And that's how I go about determining what the accuracy of the future forecast will be. So there's several ways that we can measure the accuracy of the forecast. Your textbook shows 3 formulas here. There are 2 that I particularly like, and I'm going to hold you accountable for knowing how to do these, both on homework and also exams. So the 2 that I particularly like is the first one, MAD, and that stands for, it's a 3-letter acronym that stands for mean absolute deviation. Mean absolute deviation. So another word for mean is average. So I'm going to be averaging something. I'm going to be averaging the absolute deviation, the absolute value of the error. So the deviation is the error. So if you look at the numerator, what actually happened minus the forecast, that's the error, and I'm going to take the absolute value of each error, and I'm going to do this for a certain number of time periods. So we need to have two values in order to have an average. So I need to have at least 2 time periods, but there's no maximum that I can have. So I'm going to take the error, take the absolute value of it, add them all up, and then divide by the total number of time periods. And that is MAD. Now, the reason why I like MAD is because it has a physical meaning. We can actually relate it to something. And what we can actually relate it to is this. Let's say that this calculation turned out to be 20 is the number. What that means is that in the past, our forecast was wrong by 20. It could be 20 too high, it could be 20 too low, but on the average, it is wrong by 20. So therefore, our future forecast we would expect would also be wrong by 20. 20 too high, or maybe even 20 too low. Now, the other one that I like in your textbook is the one at the bottom, MAPE. So that stands for mean absolute percent deviation. Mean absolute percent deviation. So once again, we have the word mean, which means that I'm going to be averaging something. And I'm going to be averaging the absolute value of the deviation or the error expressed as a percentage. So if you look at the numerator in the MAPE formula and you compare the numerator to the numerator up in the MAD formula, you'll see that they're very similar to each other. The error, actual minus forecast, the absolute value. The only difference is I am dividing by the actual value and then multiplying that ratio times 100. So when I divide by the actual and multiply times 100, what I'm essentially doing is converting that error into a percentage. So we were wrong by a certain percentage in a particular time period. And then I'm just taking all of those percentage errors, adding them up, and then dividing by the number of time periods. So MAPE, very similar to MADE. So we can say that MAPE is saying that on average, your forecast is wrong by a given percent. It could be too high by this percent, or it could be too low by that percent. Now, this slide shows an example of calculations for errors, the absolute value of errors in MAD and MAPE. So you can go through this, but there's going to be another unit in this chapter, Unit C, that I'm going to also be doing the same calculation. So for the sake of brevity, I'm not going to go through this slide, but I will ask you to go through and take a look at the calculations that I do on Unit C. So all of the forecasting techniques that we could think about and discuss and study fall into 2 broad categories of types of forecasting or approaches. There's one type called qualitative forecasting. In qualitative forecasting, I'm using soft information. Soft information is information that's based upon opinions, on hunches, maybe on some data that is not completely scrubbed. But still, sometimes qualitative forecasting techniques can be quite helpful. So especially if you're thinking that the future may be radically different from today. Qualitative techniques could be a better way to make a forecast. The more common way, however, of our forecasting technique are quantitative forecasting. So quantitative means mathematical, so we have some type of mathematical formula, and I'm using some historical data from the past, and again, I'm going to be making that assumption that the future has some relationship to what has happened in the past, and that is generally true, but not always. So if I'm going to be using quantitative data, I need to have a time series. So the definition of a time series is it is a time-ordered sequence of observations at regular time periods. So it's time ordered, so it's increasing in time. So you can think of a spreadsheet. If we have a columns in the spreadsheet or even rows in the spreadsheet with dates. And it's also important that the observations have a regular time period. So if we are going to be looking at historical data on a monthly basis, we can't have actual data for 1 month and then we skip 2 months, or we take 2 months and add those numbers together, because it has to be the same time period for each element, each observation in the time series. So, time series behaviors. Our time series can have certain patterns associated with them. So, one of the things we need to do to be a good forecaster is to recognize the pattern that may be associated with the demand of our products. And some of the more classical patterns are shown on this slide. We'll talk more about them: trend, seasonality, cycles, irregular variation, and then random variation. So this slide shows some of the different time series patterns or behavior. So if we take a look at the graph shown in this slide, the graph in the top shows a trend. So the definition of a trend is some upward or downward movement of the data over some consistent period of time. Now that doesn't mean that it is constantly going up or constantly going down, but generally over some period of time, it's either going up or it's going down. Now we also see in the top graph that there is a very unusual looking spike in the data, and the textbook has labeled this particular type an irregular variation. This is sometimes referred to as an outlier, O-U-T-L-I-E-R, an outlier. An outlier is some unusual pattern in the data that occurred in the past. It actually did, but it's something that we do not expect it to happen again. So in our forecasting, we would like to try to not include the outlier data in our forecast, since it's not something that we expect to happen again. Now the middle graph shows what the definition of a cycle. So a cycle is a pattern where we have a increase, and then we have a decrease, and then we have another increase. So looks a little bit like a roller coaster, except in a pattern, the distance and time, the time between a cycle, such as the top of one peak to the top of another peak, is measured in years. It could even be measured in decades, very, very long periods of time. And cycles are very difficult to forecast. The mathematics and the models associated with these are quite complicated, since the patterns repeat themselves. It takes so long to repeat themselves. Give you an example of a cycle. Our economy goes through cycles. We go through a growth cycle. and it peaks out, and then we have a recession where the economy will go down, the gross domestic product will go down, and it will bottom out, and then we will go back into a recovery cycle, and eventually it will peak out again. So since World War II, the average time between recessions has averaged about 7 years. Now that's an average. That doesn't mean that it always occurs every 7 years. It could be more than 7 years. It could be less than 7 years. So in the year 2000, we had a recession. In the year 2007, we had another recession. In fact, we had the Great Recession, as historians are calling that now, occur in 2007. So in that case, it just so happened it was exactly 7 years, but it doesn't have to be 7 years. And we could also have, in the graph at the bottom, a combination of things that's going on. So if we look at the 4, year 1, 2, 3, and 4, we can see that we have a kind of a regularly occurring increases in demand that occur twice a year. Around the April time frame, we see the demand picks up, and again we see demand picks up again in the fall and the October. So we can see that this has been going on a regular basis every year. So that's referred to as seasonality. So sometimes products have a seasonality to them. So you're going to sell a lot more Christmas trees in December than you're going to sell any other time of the year. And there's also what we see in these is we also have a trend going on. So the demand is increasing from year 2 to year 1 and from year 3 to year 2 and so forth. So we can have multiple things occur on any particular pattern. So let's take a look at the first of our forecasting techniques. We'll start with the simplest of all of our forecasting techniques, and it is referred to as the naive forecast. The naive forecast. It's called a naive forecast because it really doesn't, the formula is very, very simple, and it doesn't really need a lot of analysis. And basically what it says is that the prediction, the forecast for the next time period is going to be exactly what happened in the previous time period. So the forecast for the next time period is equal to the previous actual time period. So that's the typical way that we do a naive forecast. If we have some seasonality, we can do it a little bit different, or if we have a trend, we can do it a little bit different. But the one thing that I want you to know is that typically a naive forecast is when we have a stable time series that the next time period is equal to what we have done previously. Now let's take a look at some other forecasting techniques. So the naive forecast as well as the averaging types of forecast, these are all good forecasting methods when our time series data tends to be relatively constant. In other words, there is variation, there's differences in demand from one time period to the other, but the differences tend to kind of average around some average value. And we see this a lot in a lot of different products. So the techniques that we'll talk about here are moving averages and weighting moving averages, and also exponential smoothing. Now again, there's going to be another unit. It's going to be a spreadsheet that I want you to be sure to watch, where we'll go through examples of doing these three, and I will hold you accountable both on homework as well as in exams to being able to do these three types of forecasting. So moving averages. In a moving average, what I'm going to be doing is I'm going to be taking some actual historical data that's represented by the letter A, the actual value, and I'm going to be adding them up, and then I'm going to be dividing by the number of time periods. So how many values do I need to have an average? Well, I need to have a minimum of 2 in order to average anything. So in moving averages, I need to have at least 2 time periods to average, but there's no maximum number of time periods that I could use. It's basically a decision as a forecaster that I make as to how many time periods that I'm going to be average. Now, the reason why this is called moving, the word moving is in this title, is after I have made a forecast and then I know what actually happens and I'm going to create the next forecast, I'm always going to average the most recent periods. I'm going to drop the oldest data in my average and add the most recent or the most current data and then recalculate the average. Again, take a look at Part C of this unit to see an example of that. So we're going to drop the oldest data, then add the newest data and recalculate. Now, we said that we need to have a minimum of 2 data points to average, and there's no maximum number. So if I have a few number of data points to average, my moving average technique tends to be more responsive to the actual demands from my customer. The more data points that I average using the moving average technique, the less responsible it will be to demand. So my question to you is, as an operations management person, which would you rather be, more responsive or less responsive? Well, that's really kind of a trick question, okay? It's a trick question because it really depends on several factors. There are certain situations where you want to be more responsive, especially if you have a product that has a very high profit margin associated with it. You want to be very responsive. On the other hand, if you have a product that has a very low profit margin associated with it, being that responsive, is not that big a deal, okay? You want to keep your costs low if you have a low profit margin. So it depends on certain parameters whether you want to be less or more responsive. The next one is weighted moving averages. So in weighted moving averages, what I'm going to be doing is I'm going to be assigning something called weighting factors. They're represented in this formula by the lowercase w, and the sum of the weighting factors must equal 1. The sum of all the weighting factors must equal 1. And I'm going to be multiplying the weighting factors times some series of actual data. Now, I'm not sure who named this particular technique weighted moving averages. There's no averaging that occurs in weighted moving averages. If you look at the formula, if you're going to average anything, there's going to be a denominator, and it's going to be dividing by the number of things that you add up. And you don't see the denominator in this formula. So there's actually no averaging that occurs. But the word moving is in here. So what that moving means is that once I have a forecast for the next time period and I have the actual data and I want to make a forecast for the next one, I'm going to always drop the oldest data, add the newest data, and then do the calculations again of multiplying the weighting factor times the actual data. So once again, be sure to view Unit C of this chapter, or Part C of this chapter, where we'll go through some examples of these. This is the end of Part A. Welcome to Part B of Unit 3 on forecasting. So we finished Part A talking about two of our averaging techniques, moving averages and weighted moving averages, and we'll continue along those same lines and talking about the third, and that is exponential smoothing. So again, these techniques, along with naive forecasting, are good techniques whenever our demand pattern, our time series, tends to fluctuate around some average value. So there's not a whole lot of change, it's some fluctuation over an average value. So exponential smoothing. The formula is a little bit more complicated than what we've seen before, but it's really not that difficult. So let's take a look at the formula. The formula says that the forecast for the next time period, f sub t, is equal to the forecast in the previous time period, f sub t minus 1, plus alpha, which is called a smoothing factor, multiplied times the difference between the actuals and the forecast from the previous time period. So the actuals minus the forecast. We know by definition that that is defined to be the error in the last forecast. So all this technique is doing is saying next time period that I forecast, next month, is going to be the same as the last month plus, and we'll refer to this alpha times the error as an adjustment factor. So I'm going to essentially be adjusting last month's forecast by a certain amount. The amount of the adjustment is determined by the alpha factor. Now, alpha, by definition, is a value between 0 and 1. Alpha can be a number between 0 and 1. It can be 0, and it can be 1, and it can be anything between 0 and 1. So let's say that alpha was equal to 1, which is the maximum value that it could have. So if alpha is 1, if I multiply 1 times the error, then whatever the error was in the last forecast, then I'm going to adjust the previous forecast by the full amount of the error. Either upwards or downwards. Now the rules of algebra still hold true in forecasting. So if the forecast in the previous time period was greater than what actually happens. So let's say that I had forecasted 110 and the actuals were 100. So 100 minus 110 is a negative 10. So what does that do? The rules of algebra say? The rules of algebra says that if the value in the parentheses is a negative number, that changes the sign in front of the alpha. So that changes the sign from a plus to a negative. So in that case, I would be adjusting the next month forecast down by the full amount. Let's take the other extreme of alpha. The other extreme is alpha is equal to 0. So if alpha was equal to 0, 0 times the error is 0. So if alpha is 0, it says that the next forecast is going to be exactly the same as the previous forecast, since alpha was 0. So alpha can be 0 or 1 or anything in between. Now, the way we go about choosing which alpha value to choose, again, it determines how responsive that I want to be. The greater we set the alpha value toward the 1, the more responsive I want my forecast to be. And if I want my forecast to be less responsive, then I set alpha closer to the 0 value. So again, take a look at the Unit C for examples of doing single exponential smoothing. So in addition to stable models, we also have trends. So we could have lots of different trend curves, okay? So the definition of trend is some upward or downward movement of the data. So they can be linear trends or they can be non-linear trends. So the definition of a linear trend is when we have a straight line. We have a constant slope when we have a straight line. So the formula for a straight line is shown in this slide. So the formula of a straight line is equal to A plus BT, where A is the point where the line hits the y-axis and B is the slope of the line. Remember, slope is defined to be rise over run. So here's an example of the straight line. So A in this example is 45. That is the point where it hits the intercept, and the slope is going to be 5, rise over run. So the formula in this example is A plus 5t. So if I wanted to know what the forecast would be at some future time period, all I would need to do, if I know what A is and I know what B is, insert the value for t for whatever future time period that I wanted. So if I want to know what the forecast was for time period 5, I would insert the value 5 for t, and I know that A is 45 and B is 5, and I could calculate what the forecast would be. So these are the formulas for calculating the slope of the line and also the intercept. They look kind of intimidating. Don't worry about them. You're not going to be asked to be doing anything to do calculations like this on exam purposes. So another way that I can forecast trends if I do not have a straight line is with the formula we could refer to as trend-adjusted exponential smoothing. Trend-adjusted exponential smoothing. So in this example, it's similar to the single exponential smoothing or exponential smoothing, except now we're having two smoothing factors. We have the smoothing factor alpha, which we have talked about before with single exponential smoothing, and we also have another smoothing factor we'll refer to as beta. So the trend-adjusted forecast is equal to the forecast plus the smoothing error plus a trend estimate. So these are the formulas for the smoothing factor. Again, here's our alpha factor. It looks very similar to single exponential smoothing. And then below that is the trend factor. And we see the beta smoothing factor shown in this formula. Again, beta is similar to alpha in that it can be a value between 0 and 1. It can be 0, it can be 1, or it can be anything between the two. Now, for exam purposes and homework purposes, I'm not going to ask you to do any calculations related to trend-adjusted or trend-adjusted exponential smoothing, but you will have a exam problem on a linear trend forecasting problem. Seasonality is another pattern that we can have on our time series. So the definition of seasonality is some regular repeating movements. So we can identify with seasonality in a number of ways. So there's certain products in the year that just sell better in certain times of year. You're going to sell more ice cream in the warm weather months than you will in the cold weather months. You're going to sell frozen turkeys more in November and December each year than in any other months of the year. So there's seasonalities associated with that. There's seasonalities associated with any products. So whenever we are creating forecasts for seasonality, we can create a model where we can say our forecast is this and use an additive technique. An additive technique says that, and in November for frozen turkeys, for example, we always sell about 100 more frozen turkeys in November than we do any other time of the year. So that would be referred to as additive. Just add whatever the increase is. Another method is called the multiplicative, which means that I take what my average is and multiply it. So in November, if I sell 25% more frozen turkeys than I do any other time of the year, I'll take the average demand for my turkeys and for November increase it by 25%. So that is the other example of how to do seasonality. So additive method is just adding, and the other is multiplying it times the trend factor. Cycles. So again, cycles are defined to be some variation where the peaks and the valleys are some long period of time. So there's a lot of complicated models associated with these. We're not going to go into them. They're very, very difficult to forecast, and it takes a lot of mathematical power, in fact, computer software power to be able to forecast cycles. Associative forecasting. So this is a different type of forecasting. It is the most difficult type of forecasting that we can do. Associative forecasting is forecasting when we are going to be identifying certain variables. This particular slide refers to them as predictor variables that have a relationship to the variable of interest that we are forecasting, such as demand. So are there different variables that influence that demand, and can I create a formula for calculating the future value of that demand using these variables in a formula? So let's take an example of some predictor variables that are associated with a typical student's life. Let's say that I wanted to forecast your next exam grade on a particular course that you're taking. What could be some predictor variables that could be used to forecast what your grade will be on that exam? Well, there are a number of different things that we could identify, but a few that come to my mind are these. One predictor variable would be how many hours you plan to study or you do study for that exam. So there should be some type of relationship between study time and exam grade. Another variable would be how many hours of sleep that you got the night before the exam. So if you're sleep deprived and you haven't been getting good sleep lately, then you're not going to be as mentally alert, and that could pull your exam grade down. If, on the other hand, you get a good night's sleep, you're going to be refreshed, and that could increase your exam score. Another predictor variable could be the number of other exams you have in other courses, either on that same day or maybe within 24 hours of that particular exam. So the more exams that you have to prepare for, then that typically may pull down your grade. So to create a forecast that takes these factors of number of exams, study hours, sleep hours, and build a formula to create a forecast. So whenever we do associative forecasting, we're always going to be doing some type of regression. Regression is the process of fitting a line through a series of data points. And there's a number of techniques for doing that particular thing, fitting a line through a set of data points through a time series, okay? But one technique is called the least squares method. And here's the formula for least squares. So we can see up at the top, there's our straight line formula, okay? So y is equal to a plus bx. So a is the y-intercept, b is the slope. We saw that before. And those are formulas for b and a, which we had before. Now we'll change gears a little bit here and talk about something a little bit different. Now this is related to associative forecasting. Associative forecasting. So I have some predictor variables that I think are good predictors for the demand for the thing I'm trying to forecast. Well, before I can really use them in a formula, I need to make a couple of calculations. One calculation referred to is the correlation. The definition of a correlation is it is a calculated value that measures the strength and direction of the relationship between two variables. Correlation is a calculated value that can range from -1 to +1 and any value in between. Now let's don't get this correlation concept mixed up with the smoothing factors alpha and beta. These are two different things, okay? Correlation and alpha and beta, smoothing factors are two different things. So if I have a calculated correlation factor of +1, what that means is that these two variables are not only directly related, but they are in lockstep with each other. So if one variable goes up by 10%, the other variable will also go up by the same amount, 10%. They're in lockstep. A correlation of -1 means that these two variables are inversely related to each other in lockstep, but in the reverse direction. So if for a correlation of -1, if one variable goes up by 10%, the other variable will go down by the exact amount, 10%. And a correlation value of 0 means there's no relationship at all between these two variables. So the closer you get to +1, the closer you get to -1, the stronger the strength of the relationship, okay? And the direction, either directly or inversely, is determined by whether you're on the plus side or the negative side. R squared is just basically taking this correlation and squaring the number. It's a measure of the percentage of variability in that value explained by an independent variable. So R squared is a value between 0 and 1. So if you take -1, which you can have in correlation, -1 and you square it, what number do you get? -1 times -1 is +1, okay? So 0 times 0 is 0. So when we're forecasting, we always want to plot a line to see what the relationship is, okay? That we're doing regression analysis, okay? Associative forecasting. Plot a line to verify that we have a relationship, okay? Calculate the correlation to make sure that we have a correlation that is either on the plus side Or on the negative side, a correlation of 0 means that the two factors are not correlated to each other. After we're forecasting, create our forecast, we need to monitor the forecast. We need to see if our forecast, how accurate it was. We know that it's going to have some level of error associated with it. So we have to go and see what our forecast, how much it was wrong by, and what may have caused that wrongness, and what can we do to improve in that particular forecast the next time that we do it. So a couple of methods that we have for tracking the errors. One is control charts, and control charts is the major topic of chapter 10 in our textbook, and we'll reserve time for that when we talk to that chapter. The other is tracking signals. Tracking signals is a very commonly used way of monitoring your forecast. Purpose of tracking signals is to detect whether you have a bias in your forecast. So let's see a little bit more about tracking signals. So tracking signals is shown here, and the formula for tracking signals is the sum of all the errors divided by the mean absolute deviation. So when we use the word bias, what we are referring to is, do you have a tendency to over forecast or under forecast? Do you have a tendency of making a mistake in the same direction each time? So a tracking signal of 0 indicates that you have no bias. In other words, you could forecast, high one month or low the next month. So the greater the tracking signal, okay, if it's plus, it means that you have a tendency to over forecast by this amount. If it's a negative, you have a tendency to under forecast. It's always a good way of knowing what your tendencies are. So choosing a forecasting technique. A lot of factors go into that, as shown here, okay? How much time do we have to create the forecast? What is the availability of our historical data, and how good is that historical data from an accuracy point of view? What is the availability of good forecasting software today? How much time do we have? Now, the good news is this. Modern 21st century computer forecasting software has the ability of forecasting automatically for you any number of different forecasting techniques and automatically choosing the technique that has the lowest error, for example, the lowest MAD, and using that as your next forecast. So modern computer software really has come a long way in being able to help forecasters in this regard. So a couple of approaches for forecasting information. I can take a reactive approach from a demand perspective, okay? So if I react to forecasts, I'm going to try to adjust my capacities, my workforce, for example, to meet the demand, which means I may need to bring on additional workforce, or I may need to let employees go. A proactive approach is to try to influence the demand through some way to match up with the capacities that I have. So if the forecast is, for example, lower than what it has been, what can I do through advertising or pricing or promotion or introducing new products that will increase the demand to match the capacity that I have? From an operations management point of view, good companies always focus on improving their forecast. The benefits of a good, accurate forecast, or as accurate as we can possibly make it, has been quantified in many ways. And it's been proven that it really delivers a great impact to the bottom line, to the profit line. So small improvements in forecasting can have very large improvements in profitability of the business. And it's for this reason that good corporations spend a great deal of time in the forecasting process and always trying to improve the process. So we'll finish this chapter by taking a look at the current forecasting practices. Now, this slide does not come from your textbook. This is a slide that I created from my industry experience. So, forecasting is a process that occurs on a regular basis. It usually occurs once a month in most companies, but it could be more frequent in some companies and maybe less frequent in others, but usually about once a month. So if we look at the diagram, we're going to close the books at the end of the month, and we're going to then update our historical data and add the most recent months of history to that. Then in our forecasting process, on some given day of the next month, let's say it's about the middle of the next month, we have our computer software that's going to be doing our forecasting for us. So on the middle of the month, in the wee hours in the morning, the computer's going to wake up and it's going to automatically create a forecast for all your products. And you could either tell it what forecasting method to use, or you can let the computer software go about creating multiple forecasts and picking the best forecast itself. After that is done, then we need to do the art part of forecasting. And the art part of forecasting is to review the computer-generated forecast and basically ask ourselves, do we agree with the forecast or do we not agree with the forecast? And if we do not agree with the forecast, then we need to make corrections to it, either increase it or decrease it as necessary to match with what our history and what our intuition and what our experience tells us. The next step is to reach a consensus forecast. And we could have forecasts created by several different departments in the company: the sales department, the marketing department, the accounting department, and then we need to have a meeting of everyone, including the operations people, and review all the forecasts from all the different departments and choose which of those forecasts or some combination thereof we feel like is the best. And we will then approve whatever forecast that we choose. From that point on to the next forecast in the next month, we are going to make all of our business decisions, our purchasing decisions on materials we have to buy, labor force adjustments that we have to make based upon that approved forecast. And the next month, we're going to start this process all over again and do it all over again. So this is something that just goes on each month, and hopefully as we're going through it, we're getting better and we are improving this process and having a more accurate forecast. And this will conclude Part B of this unit. Welcome to Part C of this unit. In Part C, we're going to go through an example of naive forecasting, moving averages, weighted moving averages, and single exponential smoothing. And we'll also look at one of the error measurements, forecast accuracy measurements, MAD. So let's take a look at the spreadsheet here. So we can see that we have been forecasting in quarters. And so we have the current year, quarter one, we have know what we actually have sold, quarter 2, quarter 3, quarter 4, what we actually sold. And our goal is to create a forecast for the first quarter of the next year. And the first thing we'll do is to create a naive forecast for the first quarter of next year. Now, a naive forecast is a forecast that says that the forecast for the previous time period is equal to what actually happened before if we have a stable demand period. And our data here is fairly stable. So our naive forecast for the first quarter of the next year is going to be equal to what we had done in the previous year. So that forecast will be 634. The next forecasting technique that we will use is a 3-quarter moving average. Now, I selected 3 quarters moving average just as a simple way of doing it. Remember that we could have 2 quarters or 3 quarters, any number of quarters, but we just need to have a minimum of 2. So the forecast for the next time period is going to be equal to the average of the previous. And the previous is this period plus this period plus this period. These 3 numbers right here. So the average of the last 3 is going to be 606. I'll just go ahead and take the decimal points off and just have the most significant factor. So the average of 3-month moving average for the next quarter will be 607. And once again, that 607 is the average for the most recent 3 numbers shown right here. Now, the next forecasting method that we will use is the 3-quarter weighted moving average. So in the weighted moving averages, in this example here, what I have asked for is the most previous time period. So the last quarter, let's give it a 0.5 weight. And the quarter before that, let's give it a weighting factor of 0.3. And then the quarter before it, we'll give it a weighting factor of 0.2. So again, the sum of the weighting factors must equal 1. 0.5, 0.3, and 0.2 do in fact equal 1. So to create a forecast for the 3-quarter weighted moving average, I can put an Excel formula in. I always like to put in a couple of left parentheses here. So the most current time period, and we're going to multiply that times 0.5. I'll close that off, plus the previous time period, and that's going to be multiplied by 0.3. And then we have one more, and that is the time period before it, and it's going to get multiplied times 0.2. So 0.5, 0.3, 0.2, and we're just multiplying those times the actuals. And if we got to just so happen we get exactly the same number. It's just a coincidence that we get exactly the same number as the 3-month moving average. Now, let's go forward to the next technique, and the next technique is the single exponential smoothing. So the formula for, we like to have an alpha factor, a smoothing factor of 0.3 in this example. So the forecast for the next time period is going to be equal to the previous forecast, which is be the fourth quarter of this year. And you'll notice that we do not know what the forecast was in the previous time period. So what that means is that we really can't create a forecast for the next time period until we know what the forecast would have been for the fourth quarter of the previous time period. And we won't know what that is until we know what the one above it is, and so forth. So here's the way we're going to have to do this. We're going to have to go back and calculate what would have been the forecast in the second quarter of the previous year using single exponential smoothing. So we need to have some way of calculating that. So we'll assume that the forecast in this time period, we have to start off with something, and let's assume that we had a naive forecast to begin with. So the naive forecast is what actually occurred in the time period before that. That was 773. So we'll start the single exponential smoothing off with a naive forecast of 773. So what is the error that would have occurred in that previous forecast? So the error that would have occurred is going to be shown here. So I'll put in a formula for it. So the error that would have occurred, here's the actual, minus the forecast that I would have had, and that is the error. So the forecast for the next time period is equal to the previous forecast plus the alpha factor, and the alpha factor is 0.3, and then we're going to multiply it times the error in the previous forecast. So again, the forecast for the next time period is the previous forecast, 773, plus the smoothing factor of 0.3 times the error. And you'll notice that the error is a negative number, so what we should have is a forecast in the next time period that is less than 773. And we got 719. Now, before we can forecast the next time period, we have to calculate what the error would have been in the previous quarter. So in the first one, the error was 181. So now we can calculate what the error would have been here. And now that I know what the error would have been here, I can calculate what the next forecast would have been. And I can repeat this again. So what would have been the error here? And what would have been the forecast in the next time period? What would have been the error? What would have been the forecast in the next time period? Same thing. You notice that the error sometimes is positive, sometimes is negative. Now, I finally reached the point where I can forecast the first quarter of the next year, because I now know what the forecast would have been in single exponential smoothing for the fourth quarter of the previous year. So now, and only now, can I create a forecast for the previous year. And that forecast is 654. So we have 4 different forecasts here. 2 of them by accident turned out to be the same. So we have a forecast of 634, 62 for 607, and then single exponential smoothing of 654. So the question is, which of these forecasts is the best forecast? Well, in order to answer that question, I need to calculate what the MAD would have been for each of these forecasts. So to do that, what I'm going to have to do is I'm going to have to create the 3-month forecast formula again here in the very first time period. So just going to average these 3 numbers here. So that would have been the forecast, and I can calculate the moving averages by copying that formula down. So Excel, by the way that it does cell referencing, will automatically drop the oldest data and add the newest data, which is what we need to do in moving averaging. So now that I have this information, I can calculate what the absolute value of the error would have been in this time period here. So I'm going to put in a absolute value, returns the absolute value of a number, and the absolute value of the actual minus the forecast. And here is my absolute value. The absolute value of the error. And I can calculate the absolute value of the other errors by just copying that formula down. Now, what was the MAD for all of these absolute values? So all I have to do is take the average of these absolute values. So the MAD for the 3-month moving averages is 141. That's fairly high. To calculate the MAD for the 3-month moving average, I'm going to have to do a similar thing as what I had done before. I'm going to have to recalculate the 3-month moving averages formula. So I have the weighted 3-month moving average would have been for the third quarter of the previous year 646. And I can copy that formula, and Excel will automatically drop the oldest data and add the newest data. I can calculate what the absolute value of the error would have been using the 3-quarter weighted moving average. So I'm going to take the absolute value of what actually happened minus what I would have forecast in that time period. So here's the absolute value of the error. I can calculate it by copying that down. So the MAD for the 3/4 moving average can now be calculated by just taking the average of these MAD values. So that's a little bit higher than the MAD for the 3/4 moving average. So of these two, the 3/4 moving average is a little bit better than the 3/4 weighted moving average. But I still have one more to compare, and that is the single exponential smoothing. So to calculate the absolute value of the error in single exponential smoothing, since I already have the error, all I have to do is just take the absolute value of the error which I had previously calculated. So the absolute value of minus 181 is a positive 181, and I can copy that formula down. And let me get rid of those decimal points here. And finally, the MAD for a single exponential smoothing is just going to be the average of all these absolute values. And so comparing the MAD for the three techniques, the one with the lowest value is the single exponential smoothing. So therefore, I will conclude that of these three forecasting techniques, the single exponential smoothing with the alpha of 0.3 is the best forecasting technique, and my forecast for the first quarter of next year will be 654. This concludes Part C of this lecture.